Well, we'll go ahead and get started. Thank you, everybody, for joining us this afternoon. I appreciate your time and energy to hear from our STEM professionals and hopefully get some inspiration for your own career path and be able to ask questions. I've got some prepared questions for the doctors, and you will have an opportunity to ask questions at the end as well. So I'll introduce who we are visiting with today. Please correct me if I say your name incorrectly. I really want to say it right. So we've got Dr. Vivian U from the University of California, Irvine, Dr. Suzanne Whitney with the Cascade Forest Conservancy, Dr. Cal from PSU, Portland State, and Dr. Koenig from the Friedrich Alexander University in Nuremberg, Germany. So we'll go ahead and kick it off and get started. I am recording today so that I have a couple people who aren't able to join us, and we'll make sure that they can get the recording as well. So without further ado, we'll start with the first round. I'm gonna just kind of say a general question for everybody, and then we can take turns answering that question. The first question is, who are you and what do you do? So we can just start with Dr. Cal.
All right, so the pressure is on me to kick it off. Hi, so it's a pleasure to be here and thanks for the invitation. You can call me Raúl. The titles are overrated, so I will start there. So who am I? I come from Puerto Rico originally, and I am a mechanical engineer. Currently, I'm in Portland State University. I'm a faculty member here in the Department of Mechanical and Materials Engineering. And within mechanical engineering, which is what I do, I study fluid mechanics, and that really entails anything that has to do with air, water, and the movement of that. And you can certainly extrapolate and go into many different fields off of that. And maybe at some point I'll show you some videos and explain a little bit about what is it that you're seeing and the kinds of problems that we are interested in looking. But generally speaking, we're interested in topics like renewable energy, topics around forestry, actually, which is nice to have a person that is doing that here. We're also interested in volcanology, so looking at those processes when you have eruptions. So all of them, the combining point is the movement of air or water, a fluid. Yeah, and that's me. And I'd be happy to expand on these things and my trajectory and so on. Thanks.
Wonderful. Thank you. Dr. Yu.
Okay, so I am Vivian U, and I was originally born in Hong Kong, and I came to the States when I was in 6th grade. So I am an immigrant, but I've been here in California for a long time now. I guess I'll elaborate on my educational path later, but I am an observational extragalactic astronomer, which means that I basically study astronomy using observations. In particular, I study extragalactic objects, which are basically any objects that's kind of outside of our own galaxy. But mostly, I'm interested in understanding how galaxies evolve, and especially the supermassive black holes that are in these galaxies, how they've grown and how they've evolved through time. And I do that primarily by using observations taken in the optical and near-infrared wavelengths, so such as using these, I guess you can maybe see the ones in my Zoom background, these two Keck telescopes atop Mauna Kea and Hawaii, among other facilities that I use. But yeah, I guess I'll stop there for a brief introduction, and I can happy to expand on anything you have questions about later.
Thank you. And Dr. Whitney?
Hi, thanks for having me. Yeah, so I'm from Southwest Washington, and I am working on the ground in Southwest Washington now. I am no longer in kind of the research world. I'm definitely on the ground doing applied work. I work for a very small conservation nonprofit that takes on kind of any type of project that we think is going to be beneficial to the landscapes of the Southern Washington Cascades. So that's looking at the land kind of northeast of Vancouver up to Mount St. Helens, east to Mount Adams, and then north up to like the southern end of Mount Rainier National Park. So it's a huge landscape, very multi-use, lots of extractive practices, lots of timber, lots of recreation, kind of an area that has wilderness areas that we're excited to, you know, get to protect, but then also has like heavily managed landscapes. And so, you know, we work with a wide variety of collaborators to take on projects that we think are going to improve ecosystem function, protect habitat, restore habitat, and build resilience in the face of a changing climate. So the things that I think about are super varied. We think about, you know, what we want the forest to look like in terms of being diverse and resilient to climate change. I think a lot about fire and what is our role on the landscape in terms of fire, both when is it appropriate to actively manage to prepare a landscape for fire? When is it appropriate to actively manage to restore landscape after fire? And, you know, what part of our fire regimes are just based on natural, you know, evolutionarily appropriate processes. So I think about that. I think a lot about salmon streams and how do we get these like super important organisms to persist. I think about beaver and how do we how they impacted the landscape historically, and what are we missing now that they're not there, and how can we restore those processes. So for me, I like to think about what we can do to the landscape now to hopefully make it sustainable and have to have maybe the fewest long-term interactions to make it healthy. So that's what I do.
Thank you. And Dr. Koenig?
Hi, I'm Ollie. Thank you very much for having me. And I'm from Germany. I'm also an astronomer, and I think it very nicely bridges to the research that Vivian does, because she works on extragalactic objects and I'm mostly working on galactic objects, namely, so objects within our Milky Way. And these are mainly neutron stars, which are a type of, let's say, dead star, or black holes. So the same type of objects that Vivian works on, but they're much smaller and they're within our galaxy instead of outside of our galaxy. And I'm doing so using satellites. So I study these objects in the X-ray regime. So not in the optical, not in the wavelength that we see with our eyes, or in the infrared, but in the X-rays. This is the same radiation you see when you X-ray what is used if you X-ray your hand when it's broken. And these X-rays get blocked by the atmosphere. So in order to observe them, one needs to go to space. Yeah, that's briefly what I do.
Thank you. The next question I have is, how did you get to where you are today? What was your educational and professional path to get to where you are today? All of the students who've joined us are interested in careers in sciences and engineering and math and technology. So, you know, what were the steps that you took personally to find yourself in this career? And maybe you had a career before this that was where you started. Let's start with Dr. Yu first.
Okay. So I guess I'll start from, I went to, public schools, so middle school, high schools, and I started, having an interest in astronomy, but I didn't quite know what being an astronomer was about. So I took astronomy classes in a local community college, during the summer, and I fell in love with it. Right, it was a lot of fun learning about space, learning about the celestial objects. But I've got to admit, this is always somewhat of a joke, but I didn't really appreciate physics when I was in high school. I took it, and I think I did okay, you know, in classes and stuff, but I didn't, you know, really appreciate the value of physics actually in an astronomy education. And when I was applying to colleges, I knew I wanted to do astro, but there are some programs that were called astrophysics. There were some programs that were called astronomy, and I was like, I don't know what the difference is. I'm just going to apply and see where I got into. Eventually, I got into a number of schools, and then I actually picked the astronomy program at Caltech, and that was because it was called astronomy and not astrophysics. I was like, well, I can maybe do astronomy without physics. It was quite a mistake, I learned. But fortunately, it was in college that I had really great physics professors, and I, you know, really had a good appreciation for physics and was able to build a good foundation. And I think most importantly, I was able to reach out and have research opportunities when I was a freshman, you know, during the summer. And so I was basically pursuing research in all the summers during my college years. And that was when I first found out really what doing research is about and being an actual astronomer was about. And that was, you know, taking data, you know, answering science questions, trying to write about it, trying to answer them. And so basically by the end of college, I knew I wanted to go to a PhD program to become an astronomer. And so that's what I did. I went to a PhD program in Hawaii. That was because I knew they had really awesome facilities that I could use to observe, not to mention the beautiful beaches and things. I mean, those are just kind of a side thing, right? And so I went to Hawaii for my PhD. And actually during that time, I spent a few years over at Harvard Smithsonian Center for Astrophysics to work with other astronomers in Boston. And that really broadened my network a little bit. And basically had my PhD in astronomy. And after that, I did postdocs, which are basically these years where you're concentrated on, you know, really trying to focus, develop your research programs and trying to answer questions and write about them, publish papers, share your results. And then I'm here where I am today. So as an astronomer, doing what I really like. So that was the path I took.
Fantastic, thank you. And Suzanne.
Yeah, so I definitely took a while to figure out where the direction that I wanted to go within conservation, but I've known for a long time that that was the general path I wanted to go. So I did a bachelor's degree in biology, and then after that, I spent a couple years teaching environmental education. And after that, I was like, this isn't very sustainable. Like, you know, this is a great job for being young, but where do I want to go next? And I knew I wanted to work in conservation, but I was like, do I want to work in science? Do I want to work in policy? You know, I've always kind of had an academic aptitude towards the science and math, but I'm also someone who really likes to be out working with people. So I was like, what do I want to do? So I ended up doing an interdisciplinary master's program just in environmental studies. With a little bit of policy, a little bit of science, this and that, kind of just across the spectrum environmental issues. But while I was doing that, my thesis that I ended up getting involved in was looking at wetland bird conservation and looking at historical data of wetland birds. And I started to get into birds, but then I thought, I didn't feel confident as a birder. You know, a lot of people who do bird research are just, they have the ear for it, they have the eye for it. They're just the type of people who go out and learn it all so fast. And I was like, oh, I'm not good at this, but like I'm good at the number crunching side. So I ended up both for my master's research and my PhD research, thinking about bird communities, thinking about community usage of wetland habitats, how wetland habitats change over time, but doing it purely from the perspective of data mining, pulling historical data across like broad spatial extents, broad temporal extents, and trying to look for kind of like emergent patterns in what's going on with wetland bird communities in response to various types of habitat change. And that was fun and interesting. But then it kind of came to the point where it's like, the skills I'm building right now are kind of setting me up for a lifetime behind the computer, and kind of just purely like the analytical side. And, you know, within my coursework and my cohort, I was learning a lot about the ecological principles, but a lot of the skills I was really developing were that analytical side of things, which I was like, oh, like I'm good at this, but like, do I love it? And I did not. I did not love it. So I finished my PhD and ended up thinking like, what do I want to do with this? And really like what I like to do is kind of the conservation generalist side of things. So ended up looking for like nonprofit jobs where you can do some of the science, some of the advocacy, some of the outreach, get to spend time on the ground collecting some of your own data, and then also, you know, like helping people using that analytical side of things to help people with their data. So that's where I ended up in a couple different nonprofit jobs, and now the nonprofit job that I'm in currently is very much a little bit of everything. It's that kind of like broad conservation work. And I would say it is a job that does not require a PhD, just to make a plug for that. You don't have to have this like straight academic path. But yeah, that's where I am now. And I've gotten good at birding. So just took a long time.
Thank you. Raúl.
Okay, so my path. Like I mentioned before, I am coming from Puerto Rico. So I was there until my years through high school. And to speak a little bit about that, I was always interested in science and mathematics. I always had a passion for it. I felt that I was good at it. I felt that was something that I really wanted to pursue. So I looked at what kind of possible majors I could go into when considering the fact that I have this tendency to like those subjects. And I came or converged on architecture and engineering. And from those, I started thinking, okay, I started talking to a few architects, started discussing with a few engineers, and started understanding, you know, what was their daily life like, what kind of jobs they were doing, and why is it that they were interested in those particular fields. And in the end, I ended up converging to engineering. And the reason for that is because I felt that it was a bit more exact rather than architecture, which I had have a tendency to also like. So in the end, I decided to apply to a bunch of engineering schools, or to schools for engineering, I should say. I knew that I wanted to do something physical, which meant that I was more geared or lean towards mechanical engineering, simply because of the physical nature of it. And I applied to a bunch of schools and ended up in Rensselaer Polytechnic Institute in upstate New York. So I took a plane, went from the very hot weather to the very, very cold weather to the very, very, very cold weather. You know, where plenty of snow. And there I decided to do mechanical engineering. At first, it was not clear to me why that. And very quickly you start taking courses and you converge and say, okay, this is it. This is what I want to do. I want to be an engineer. And over the summers, I took internships at different companies, where I started working within a consulting company, and that was coming back home to Puerto Rico and doing internships there. I also did internships in the United States, in Michigan, with General Motors. And very quickly I realized that I didn't necessarily see myself doing the jobs that these people were doing. So I started discussing with other faculty. I started knocking on doors and getting interested on research. And once I did that, I had the opportunity to start doing research with this one person. And this was when I was 20, so almost towards my last year. And at that point, I had a job offer. So there was a big bifurcation whether to go into the industry world or to say, okay, let's carry on doing research. And I had the opportunity to do some experiments in Canada in a massive, massive, massive wind tunnel. And at that time, that just took my heart and said, okay, this is what I really want to do. This is incredible. You could walk into the tunnel, turn on the tunnel, and feel the air. It's just like when you stick the hand out of your car, and that was it. So it was impressive, incredible, a wonderful experience. And that's what I did. And I decided to follow on to a master's there at Rensselaer Polytechnic Institute. I finished my master's in fluid mechanics within mechanical engineering. I said, okay, I still dig this. This is wonderful. Let's carry on. So I went for a PhD. But at that point, I said, I've been here in New York at this place for 6 years, bachelor's, master's. I'm sick of this place a little bit. So I had the opportunity to travel abroad to do a joint PhD program between Rensselaer Polytechnic and a university in Sweden. And that was brilliant. That was exactly the kind of fresh air that I needed. It was still in fluid mechanics. And there I got to do a whole bunch of other set of experiments, pursue my PhD. And I kept going back and forth between New York and Sweden, Gothenburg. It was also incredible to be able to experience the multicultural side of things, interact with other people, interact with other scientists, and I completed my PhD. After that, similar to the previous person, Vivian, who was saying the postdoc, I also took on a postdoc that was in Baltimore, Maryland. The reason for that is I really wanted to work with this one person. He's a superstar. And I said, I really want to work with you. So I went ahead and went for it. So ended up there, was there for about 2 years, did some pretty incredible science, again, still in fluid mechanics. And it was time to move on. So I applied for a job here in Portland as a faculty and in the Department of Mechanical Engineering. And luckily I got it. And I've been here since. It's incredible to work here. I love it. I wouldn't change it. I think it's incredible. And I'll talk a little bit about later, why is it? I think that's the next question. So I'll stop there. And yeah.
Thank you. Ole.
Yes, so I was always really interested in I'd say like the superlative, like the really big things in. I would always ask questions like, oh, how big is the Earth? How big is our galaxy? Like how much distance is in between the stars? And I always try to imagine it. And yeah, as a child, I was always super fascinated about space and everything that was connected to it. And in school, I was good. I was always good at math, but like Vivian, I was not particularly like into physics actually. And then more through a coincidence, I actually got into studying physics, which at first I thought like, oh, this is like way too hard. Like this is super hard math and I'm not going to make it. But I absolutely love it. At university, it was a totally different story than in school, in high school. I think it's very much related to what teachers and what professors, like who tries to teach you these things. And yeah, absolutely loved it. And then became a physicist, did my bachelor and my master's in physics here in Germany. And then I did an internship at the European Space Agency in Madrid, so Spain. So this would be the European counterpart of the NASA. And yeah, that was where I developed like a real passion for research, and I really got into my like this particular topic of research on compact objects, so neutron stars, black holes, white dwarfs. And yeah, that's when I also decided, yeah, I do not want to go into industry. I would like to carry on doing a PhD, and I applied for a PhD in Bamberg and close to Nuremberg in Bavaria in Germany, and got that position, and am now since like 1.5 years doing my PhD. So I should say that I do not yet have that title of a doctor. I'm getting it. I'm trying to get it, and yes, this is where I stand right now, and I'm having lots of fun. So that's very good.
Excellent, thank you. Well, let's go in the same order but reverse this time. What do you love about what you're doing? So we'll start with Oli.
Yeah, I think it is exactly that childhood thing that I always loved space and what is connected to it. I think it really was this sort of childhood dream. Actually, when I was really young, I always was like, oh, I want to be an astronaut. But then it turned out like becoming an astronaut is incredibly difficult. Right, yeah, there's actually a picture of what I'm doing. But let me finish that story, right? So I was like, oh yeah, I'm gonna become an astronaut, but yeah, super difficult, obviously. But then I was like, oh, and in that case, I'm gonna be an astronomer, although I was like 5 or 6, so I didn't really know what that meant. But yeah, for me, it's really like the fulfillment of a childhood dream, I'd say. And yeah, it's also, I think, in astronomy, these objects we're looking at, they're incredibly difficult to imagine. I think a black hole which weighs, I don't know, like 10 times the mass of the sun, or even like millions or billions times the mass of the sun, it's so difficult to imagine it. And what we're trying to do is to draw the picture. How does this black hole actually, how does it sit in space, in the universe, in space-time, and how does it interact with the environment? And we're basically trying to get from that non-imaginable picture into an imaginable picture, if you can say so. Yeah, here's one type of object I'm working with. I don't, let's not get too much into detail here, but basically what you see here is the black hole is basically the very the dark spot in the middle of that red disk. That is where the black hole sits, and matter is falling into that black hole, and that's why the surrounding becomes white glows, and then also jets or so material is ejected from the vicinity of the black hole into space. And you can study all of that in using optical, using the ground-based telescope, but also using X-ray satellites. Yes, I think I will stop here.
Thank you. And Raúl?
Yeah. So what do I love about my career? Okay. What I love about my career is that it is very challenging. I also love about it that I get to work on problems that are challenging, and I get to define those problems. So I get to decide on the problems that I want to work on. I get to do crazy experiments. I get to interact with students that are brilliant. I get to interact with colleagues that are brilliant, and we get to exchange ideas, and we get to just hypothesize and muse about particular problems that we might be interested in. And this, again, can go in all sorts of directions. I get to bounce ideas with these people, so it's a very collaborative nature in what I do. I get to have an impact on students, and I get to have an impact on their development. I get to have an impact on science because of the kinds of science that that we're we're doing. And I also get to develop myself and learn about myself, the kinds of things that I really like, the kinds of things that I don't like, the things that the kind of things that I get to improve on myself, and the kinds of things that I know that I'm quite good and get to expand on that. And what else do I like about my career? I think that I could get more into, maybe it's a good time to share a little bit. If I can share my screen very quickly, if you allow me to do that. Okay, here we go. So maybe I'll show you. Okay, continue. Desktop. So maybe I can show you a couple of videos of things that we are doing. So hopefully, can you see my screen? Yes, maybe. Okay, perfect. So this is called a drop tower. And this, we get to launch and drop things at a very, very high speed. Maybe it's, let's see if it loads again. At very high speeds. And there we get to replicate things at non-gravity environments. So that's, we get to be in space without being in space. And in this kind of experiments, then we get to study the fluid mechanic of things. And I can show you a couple of videos on that. And hopefully you saw this capsule shooting down. And this is 5 stories that is just going really, really fast. And here, maybe I can show you the kind of fluids or that you might be able to visualize. So you see things like this, right? So this is a droplet that, as it's being impulsed or expelled, and it's in low gravity again, we get to look at objects that look like this maybe. So these are different shaped objects, and they get to be expelled from this hydrophobic surface. And here it goes, and we get to study what the movement of them and what they do in this low gravity environments, and the applications are massive. We also get to do things at a larger scale, and maybe here for that we use a wind tunnel. So here is a picture of that, and this is one of the problems that we might be interested in doing, which is looking at offshore wind power, which I hope that you know why that is important. And this is the kind of experiment that we do. And you can see they're moving. We're trying to understand the extraction of power, how to make them better, how to improve. Plenty of questions around that. So anyway, that gives you a little bit of how we do things and what I love about what I do. And I'll stop sharing.
Great, thank you. And Dr. Whitney?
You know, it's funny because I feel like Raúl's field and work environment are so different than mine, but like so many of the things he said are kind of like what I feel about my job too. Like the ability to create my own projects, the ability to be like, what, you know, there's all these different opportunities. Like, what is going to be impactful? What is going to be interesting? What is going to be useful? And like just getting to develop those projects, and also like the collaborative nature. It's for me, so I work for this really little nonprofit, but because we work on so many different projects, it's like each different project, I get the opportunity to find someone who is smart and an expert and experienced in like a specific thing. And I get to dig into their brain and learn about what they're doing. You know, so we're doing this beaver restoration project, and, you know, I don't know anything about amphibians, but it's like, we're able to connect with people who, you know, are working on the amphibians that live in beaver ponds, and they want to know our data for this, and we want to know their data for this. And then, you know, all of a sudden you're connected to someone who's like, oh, I'm going to go do, you know, eDNA collections in these areas. Like, and then we're like, oh, we could use that on this other project where we're looking at lamprey and whether or not they're in these streams. And like, now I'm going to go find the person who's an expert on this and like dig into their brain. And you know, I had never done botanical work before like 3 years ago, but now it's like I'm leading some like post-fire revegetation projects where I'm like getting to learn all these native plants in these areas that I've never spent time in before. And I'm getting to do that with people who are experts on the native plants of those particular areas. so for me, as someone who loves just, again, like being a lifelong learner and someone whose brain loves going in lots of different directions versus kind of being like a specialist and an expert in a particular thing, it's just like such a cool opportunity for me. So I love that. I also just love these forests. You know, I grew up tromping around in these forests, and like, I feel very lucky that I get to, you know, sleep in the forest for work, you know, multiple times a month throughout the field season. And, you know, I think one of the things in a lot of careers is that like the further along you progress up a hierarchy, sometimes the more removed you get from the aspects of that career that you really liked in the first place. I mean, you know, you get sucked into more grant writing or more reporting or more managerial stuff, committee assignments. And at this point, I'm trying to avoid all those. Well, I do have to do a lot of grant writing, but grants that I want to write on. So I'm trying to avoid a lot of those extra tasks and, like, you know, keep with the things that I love about and that brought me into this field, which is like getting to be in the woods, getting to be hands-on, and getting to just keep learning about stuff. So, and working with people on it. We bring a lot of people out to help us steward the land, to plant trees, to pull weeds, to collect data. And so that's so fun, getting to just like interact with people, teach them about the science, learn with them, and then hopefully like instill a little bit of a conservation ethic in them that they can then take home and share and change the way they vote or change the way they spend their dollars. So I feel like it has an impact.
Thank you. And Dr. Yu?
Well, I think I'm going to echo a lot of what's already been reflected on by the other panelists, you know, in terms of being able to work with people, defining your own questions. And, you know, specifically like Ole, I also had that, you know, astronaut to astronomer kind of transition. I guess that's fairly common. And for me, you know, I really, maybe I will also share my screen for just a second here to show off a little bit of let me try that again. Okay. Yeah, so I just wanted to kind of show off a little bit, you know, the type of objects I study. You know, these are the nearby galaxy mergers, right? These are galaxies. A lot of times you might see normal galaxies, they're spiral looking or elliptical looking, but these are kind of the weirdos of galaxies, and they're going through a transition process. And basically, when I first laid my eyes upon this Hubble Space Telescope press release, you know, over a decade ago, I was like, this is what I want to study. These are like eye candy, and I'm so interested in this. And basically, this is sort of examples of galaxies that they're colliding with each other. And I wanted to know how they're doing that, why they're doing it, what happens when they're doing it, what happens to the black holes inside them when they're doing it. And so, you know, being in the position I am now, I get to actually, you know, use telescopes to try to understand this process. And I think the mere, you know, ability to be able to do that really excites me. And I think I mentioned, you know, just like others, and it's sort of like when you're doing research, you're really becoming an expert in the field. You're kind of, you know, being some of the people and the only people in the world who may know about certain aspects of these things. Obviously, you want to share that, but you are the experts. And especially being an observation astronomer, a lot of what my work is tied to the facilities that are becoming available. So, for instance, after the Hubble Space Telescope, one of the successor that's going to be launched later this year is the James Webb Space Telescope, which you may or may not have heard about it, but it's an infrared space telescope that's going to hopefully be launched in October, and it's going to, you know, have very, very sensitive instruments, you know, things that we've never built before. And if everything goes well, then, you know, we'll start taking observations next year. And it will start taking some of my observations of these galaxies that I just showed you starting next year. And so there are questions that I set out to ask, I set out that I want to answer by doing those proposals that I'm now really getting excited that we get to answer. But more so, being in this kind of almost a discovery space, right? You're using new instrument, you're pointing at the sky, you're pointing at these objects. You may not even know what you'll be getting. And so it's sort of that excitement that you're treading in the unknown. You're really at the kind of forefront of these research frontiers that really excites me about the research aspect. And then I mentioned I use a lot of ground-based telescope, and so definitely not to ignore side effects is that you get to travel a lot to really exotic places. To use the telescopes, to collaborate with people at different places, learn about different cultures and things like that. So I really enjoy the traveling aspects as well of my career. That was something I didn't expect that I would get to do as an astronomer. And also in the position that I'm in now, I get to mentor students, I get to mentor postdocs, so kind of that nurturing of that next generation of scientists is something that I super enjoy doing. Part of what made me say yes immediately when I got to get an opportunity to join this panel. And so so I think and the other part is that I'm also trying to get involved in thinking about the next generation of facilities, for instance, and that it's all kind of tied to thinking about not just what science I can do, but what kind of science maybe next generation of astronomers can do, and trying to facilitate that, to enable that. And I think as a humanity as a whole, like what can we do? How can we answer these questions about space and everything, and helping to be a part of what can shape those questions and shape what can be done about those questions. It's really what I love about being in this being an astronomer that I am. So thanks.
Wonderful, thank you. Our last official question, and then we'll have, I think, a little bit of time at the end for student questions as well. What advice would you give to students considering a career in your field? I'd love to start with Raúl.
Okay, so I'd say be open, take risks, have fun, knock on doors whenever you arrive at even now, right? Even now as a high school student, dare to have an opportunity doing research at someone's lab, dare to do that over summer or during the academic year. When you're arriving at your institution, get involved in clubs. So really venture out and see what you like, see what you don't like, because for sure there are many things that you'll likely like, and there's many things that maybe you are not so interested in. Arriving and converging at what you really love, I mean, that's great, right? Because if you're doing after that the job that you are always dreamed of, I mean, that's great, right? And I'd say, yeah, be really acute for any opportunities. That would be my advice. Oh, and maybe one more. Don't be scared to fail. That can happen sometimes, and that's fine. You can just reassess and see what you learn from that, and you say, okay, that's fine. I learned this. Let's do it. Let's do it again, or let's do something different. No problem.
Fantastic advice. Thank you. Ole, same question.
Yeah, I think my top answer to that question would be, in my field, don't be afraid of math. I think it is in all of these, like engineering, natural science, computer science, all of these STEM subjects, they tend to have a lot of math, and it's not like it is in school. And it is really fun if you get into it, and if you get into it in a peer group, you get to work on these homework problems with your friends. Yeah, I think be open to that, and don't be afraid of it. It is certainly a big part of STEM-based science, the math, but it's not impossible. Certainly not.
Thank you. And Dr. Yu?
Yeah, I guess I would also echo the definitely be open-minded and seek opportunities to try things out. If you think you hate physics now, it's possible that you might become a physicist. You just never know. I think you should definitely try different things and find out what you like, and hopefully I think basically you really want a career that you you enjoy doing it so that you don't feel like, oh, I have to go to work. It's more like, someone has told me once that if you return from a vacation and you're like, enjoy jumping into work, then you probably found the right career. And I've had that experience myself. So I encourage you to hopefully, search through your passion and find that. And as far as, becoming an astronomer or physicist go, yeah, definitely the math, the physics are both important, but also the computer science skills is getting to be increasingly important. I think that's something you should consider studying, either informally or formally to some degree. I think that would be very helpful towards either a career in astronomy or physics, or even in broader fields. And that's something I would encourage you to keep in mind.
Thank you. And Dr. Whitney.
Yeah, I think that a lot of good points were made right there, and just like not being afraid, like jumping into things, knocking on doors, talking to people, making connections. I think those things are all super important. I think that, there's a huge advantage in a lot of academic pursuits if people are able to like go and do like free internships and free volunteering, and it's a real bum. I mean, it's a great opportunity if you're able to do that, but it's a real bummer for, I think, a lot of people who, from an equity standpoint, because there's a lot of people who are being held back, I think, because they aren't able to go do the free internships and the volunteering and stuff like that. So, I would say, like, if things like that feel unavailable to you, if you feel like, oh, I can't commit to, like, I'm seeing these advertisements for like the 6-month unpaid internship that, that I would want to do like while I'm in undergrad. I would say maybe just try and be bold and like talk to potential places that you could volunteer and be like, I can't commit to this 6-month thing, but like be honest about what you can commit to. Like, I would love to be able to come in for X number of hours a week and work with you. And, be bold and be like, is there some way that we can figure out to get a stipend on this? Is there some way that we can, is there some way that I can pair maybe an opportunity where there's some paid work doing something that's a little more boring, some paperwork, and then get to, complement that with some time getting to do some more like some hands-on work that would give me more experience. So, I know that in my world in particular, it's a hard field to get into, and sometimes it's a lot of who you know. So just trying to make those connections and being honest about like what you have the capacity for can make a big difference. And for me, if someone wants to come out and like spend a whole weekend planting trees one time, could be really impressive, and I'd be happy to give someone a reference after they do that. But yeah, building those connections is important. Also, conservation being a not as highly paid field as some of the other STEM fields, I would highly recommend, when you're thinking about grad school, thinking about doing it in a way that doesn't get you into a whole lot of debt. There are lots of ways to pay for your graduate education, and I see people all the time through assistantships, fellowships, other opportunities, and I see people all the time who are afraid to go to grad school and do an assistantship, and they end up taking on all this debt. And I would just highly encourage you to find a way to get your graduate education paid for, and don't do that, especially if you're going into conservation, because it can be a real impediment.
Thank you, and thank you for your honesty. Okay, now is the part of the panel where students, if you have questions for either a specific person or for the group as a whole, you can put them in the chat, or you feel free to unmute and ask your question. And yeah, we've got a little bit of time for that. If you've got a question that you'd like to ask, chat or unmute. For all of our guest speakers, or for one person individually. Don't be shy.
Yeah, so it's been great hearing all of you guys talk about like how you got to where you are today and what you do. But I was wondering if for any of you, if you can think of one thing that you like were excited about the most, or your favorite project that you've ever done, or something like that, something along those lines.
I know everybody's got a favorite project, though.
I can start. For me, it's usually the next one, whatever is new. I get super excited. Now in hindsight, thinking about the past, because you asked for one, I'd say I will mention two very quickly. So one was during my undergrad, was doing my capstone. So it's the senior year design project. We got to do a self-tuning guitar, and it sounds pretty ridiculous. It was pretty radical. We had a lot of fun, and it was a team of 5 people, and we just got to interact a bit and design this thing that would tune itself. And then during my postdoc, I was fortunate enough to be able to do this one experiment and work on this one project that sort of opened up a whole series of experiments after that. So those are that's my answer.
I can go next, a little bit like what Raúl was saying, kind of the next one. But when I was trying to study those galaxy mergers that I showed you with the Keck telescopes, we found molecular gas that's sort of sitting in the center of these galaxies around these supermassive black holes, but there's still aspects of it that we didn't understand. We found some really interesting targets. They seem to be spewing out these molecular gas, but we can't really see that close to the center because the center of these galaxies are very dusty, and we really need high resolution, high quality infrared instruments to see these things. And as I mentioned, the James Webb Space Telescope is a great opportunity that's coming along, happening like literally now, or well, hopefully later this year, that we were fortunate enough to get have a successful proposal to get approved time to look at it. So, that is going to be answering the question, and I'm so excited to be able to see, whether or not our thinking for validated, what else we're going to see about these molecular outflows and center of galaxies, and yeah, super excited.
I think in my case, it was probably the time at the European Space Agency in Madrid, because I always had this impression or this image in mind that at the places where you actually operate the satellites, there would be like loads of displays, and it's exactly like that. It's super cool, and I was just stoked about it.
Yeah, a couple things I think of. So one is like after finishing my dissertation, which just involved massive spreadsheets and massive numbers of all these different community metrics and blah, blah, blah. I feel like some of my best days after that were when I had a whole day of hiking, and then all the numbers I had to think about were counting to 2 or something. I just hiked across this huge stretch of this island and found this one pair of bald eagles nesting, and we know that they're nesting, and that this one that we thought maybe was gone is still here. I feel like some of those are my best days. They're when we're hiking in the GP to go find a remote camera, and we're this has been out here. This camera's been out here for a year, snapping all winter when something goes by. Are we gonna get a wolf? Are we gonna get a wolf? Are we gonna have to change all of our policies around wolves because the wolf's gonna finally show up in this particular region? I feel like those are some of my favorite moments of work. Also, because a lot of my research when that was my job was kind of finding different ways to prove that wetland birds like wetlands, which can be interesting analytically, but not very satisfying ecologically. Moving into my job now where, we can finish a season of data collection on how huckleberry plants are doing after different logging treatments in the forest, and be able to collect data, analyze it, and be hey, look, this thing you did where you actually were able to extract quite a bit of timber from this area was actually okay for the huckleberry, and this was not. And like be able to make a real recommendation to the Forest Service and be like, this is a win-win. Like here we can like protect this ecologically and culturally important plant, and also, you know, maintain kind of the multi-use mandate of this forest that we're on. So kind of finding those win-wins on kind of the applied side of things has been very satisfying for me lately.
Thank you. Thank you all. Oliver's got a question in the chat. What's the most difficult part of your career? Great question.
I'd say for me, it's handling computer grids. I'm having great trouble. I should explain this a bit more. So in the research I'm doing, you have to calculate a lot on, it's very, very calculation intensive. So I'm doing some simulations, for example, of these black holes, and it just takes quite a long time to achieve these simulations. So what you do is you send these jobs, so to say, these the tasks to actually do the number crushing to a grid of computers, to multiple computers basically, and to handle that is it's not always easy.
I think for me, a lot of it's just like prioritizing things, trying to because my job is so broad, it can be really difficult to be like, what is like the best, what is the project that's going to be the most beneficial? You know, what is, where do we focus our energy? You know, and I think one thing, so my organization is kind of going through this switch where we're kind of pushing more resources to like the advocacy side of things, which I think is super important. Like as someone who cares a lot about conservation, I feel like that's super important. Like if we can just like protect big chunks of land, like that's going to be more important than like any tree I get in the ground. But I don't really want to spend my day doing advocacy. So like thinking about those prioritizing, like if our job is to protect this landscape and all the different components of that, like what is the most useful? How can we use our time best to get it done?
I guess I can talk a little bit about perhaps the competition, you know, that is in the field, you know, for resources, and that includes telescope time, that includes funding, you know, in general. It's one part is trying to you know, find permanent positions that are, you know, more limited. There are probably fewer permanent positions than PhD students in my field. Definitely a reality that we all face with. But also, even when you're in position, you want to support your students, you want to support your postdoc, funding is also important to get. And these funding can be anything from like several to 1 or 10 to 1 or whatever the ratio is, the oversubscription factor. And so I think part of it is, you know, part of it's luck, but part of it is also maybe another skill that I would add to that you should probably hone in on to become a researcher, to your writing, your communication skill. You know, when I was growing up, I was like, oh, you know, I love math and science. Who cares about writing? Oh, language arts. But, you know, it's so important. It's like basically the thing I do every single day. You know, I also, you know, code and look at data every single day, but writing, I definitely have to do that. Like, you know, constantly writing proposals, writing papers to communicate my science, communicate my idea, and to do it effectively and to be able to articulate why I do what I want to do and why it's important. And so I think, you know, that it's part of the fun, but it's also, you know, I would say a lot of us are kind of more used to rejections than acceptance in some cases. And so you have to be, you have to learn how to fail. You have to learn to accept failures and move on. And so, you know, kind of, it's not, there's several aspects. I touch upon several things here, but I think some of those aspects are definitely some of the more difficult part of my career.
Yes, I will echo what Vivian said. On my end, that's it. Nail it. So growing a thick skin and being able to get a no, funding and practicing communicating your ideas in a very, very clear way, fast way that, okay, I get it. I get why this is important. Also on the teaching side, making sure that you can adapt the material to the entire student body. People learn in different ways, whether it's in a more traditional way or visually or even outside of class. So being able to adapt to that, it can be difficult, but it's always something that that I strive for. And I think that I was a little bit unfair when I was discussing my path, because I discussed it in a quite positive way, like nothing along the way came along. And I think that it's important to also recognize that at times it'll be difficult. So I think that you'll have to make tough decisions. Like, for example, for me, it was, okay, do I stay home or do I leave and live my life many, many kilometers away from home, for example, or having people tell you, no, you cannot do that, or you will not succeed in that. So taking no for an answer, I think it's also a good thing to do. Don't, if you believe that you can do something, go ahead and try it out. Don't let anyone tell you, no, you cannot do that. No, that shouldn't be. And also, you have to be self-critical, but not be too harsh on yourself. So in other words, don't be scared to take opportunities. So meaning, okay, I'm going to send this application and let them judge. I mean, if you don't make it, that's fine, but you have to send it. You don't be the judge where it says, okay, I'm not going to send the application. I don't think I'll ever make it. So I think taking those risks, taking those opportunities, such that then you can position yourself and have the ability to say, okay, now look, I have the ability to do it. So now it's on me to say yes or no. So I think that those things happen to me along the way. So I can speak about them as a first-hand experience. So I'll stop there on that.
Thank you all. We've come to the end of our time together today, but I'm just bursting with energy and ideas around all of the topics that you touched on today. So I want to say a huge thank you to our students who've joined us today. I hope that this was valuable to you, and just infinite thanks to our professionals who've joined us. I really, really, truly appreciate the knowledge that you've shared with us, and the honest portrayal of your careers and how you got there, and what's exciting about them. I think everybody will leave our event today inspired, and with a lot of food for thought for what the future holds. Thank you so much to everybody. I did record this, so if you missed the beginning, I can share that with you. And I know a couple people who weren't able to join us, but from the bottom of my heart, thank you all for being here this afternoon. I am excited for the work that our professionals are already doing, and the future work that our students will be doing in the field as well. Thank you.
Thank you.
Thanks for having me.
Thank you. Bye-bye.